HA2, this is my last video in this individual module on using trigonometric identities to do two things, really to evaluate trig functions as well as to rewrite or simplify trigonometric expressions. And so let's recall that we have our list of fundamental trig identities over here on the right. I would say that the holy trinity, the main three, the ones that you want to pay attention to really are your reciprocal, tangent, and Pythagorean, but also that from time to time we use our cofunction identities as well as our negative angle identities. So focusing on these top three really is our priority. But let's take a look at kind of putting these to use. So on number one here, it seems that we're given the value of cosine like right off the bat. Okay, and we're also told that our angle is somewhere between 0 and pi halves. And so one thing that I do want to make sure that we do is sketch out our angle. And our angle, all I want to know is that it terminates in the first quadrant here. So what this is going to mean is with respect to all of our values that we find, they should all be positive. So that being said, what we want to do is find the other trig function values. And so because we know that the cosine of theta is equal to 1 over 6, recall that it's very fair to say that using our reciprocal identities that the secant of theta is really 6 over 1. So I'm just going to go ahead and start by throwing a box around that. Now with respect to finding the rest of these, we have cosine and secant, looking down at our Pythagorean identities. Remember that these Pythagorean identities are nice because they say that if you know one trig function, you could plug it into any of these spots here. Look, we have cosecant, cotangent, secant, tangent, cosine, sine. Into any of these equations, but you could solve for one of the other trig function values. So what I'm attempting to do here, what I'd like to attempt to do here, is to take that cosine value, go plug it into our Pythagorean identity here, and go find sine, because now if I knew sine and cosine, then I could go find tangent. We could use reciprocals to find the rest of our stuff. So let's go ahead and start with this. We know that because the cosine squared, let me rewrite that. Let's do this. Sine squared of an angle plus the cosine squared of an angle is always 1. This is our primary Pythagorean identity. Then what we're going to do is we're going to say, well, then the sine squared of our angle plus the cosine squared of our angle is 1, even if cosine is equal to 1/6. So because this is true, what we're going to do is simplify and solve for our sine value here. So we have sine squared of theta. When we square our 1/6 here, square our 1/6, we get 1/36, and this is equal to 1. And our job will be to get sine by itself now. So if we were to do that, then of course we would subtract 1/36 from both sides. And the nice thing about that is we get 1 minus 1/36, which recall is easy enough to find because that's got to be 36/36 minus 1/36. Basically, it's the other 35/36 that are left over here. So 35/36 is equal to the sine squared of theta. The thing here is that we have to take the square root of both sides. So interesting on this one here, we end up with just the sine of theta is equal to the square root of 35 over 6, and this is a plus or minus. Now, in terms of which one should we keep though, plus or minus, which one should it be given that our angle does terminate in the first quadrant? And so because all trig functions are positive up in the first quadrant, we're actually just going to keep the positive here. So good news, everybody. Not that we can't simplify. Well, the good news is you don't need to simplify the square root of 35. But that's not the good news I wanted to deliver. What I want to say is that the good news is now we know sine. And therefore we know, of course, the cosecant of this angle has to be its reciprocal. So it'll be positive 6 over root 35, or we should certainly call this 6 root 35 over 35. Okay, so now we have our cosecant and our sine, our cosine and our secant. What we're going to do now is we're going to use our tangent value, or at least our sine and cosine value, to find our tangent value. So with respect to sine, we say sine, we were able to find out that sine is root 35 over 6. So we have root 35 over 6. Our cosine value was given as being 1 over 6. So multiplying by the reciprocal here, we get root 35 over 6 times 6 over 1. And so what we end up with here is just root 35. So the tangent of our angle is root 35. And because the cotangent is its reciprocal, then the cotangent is 1 over root 35, or root 35 over 35 once it is rationalized. Okay. So again, using trig identities is kind of nice to be able to determine trig function values if you even know just one trig function value. So for these other three examples here, what I'd like to do is simplify these expressions. And recalling from the last video, what we're looking for is things like, can we do any algebraic manipulation? Like, is there any distribution, foiling, okay? Is there any factoring that we can do? Also looking for things like, can we add or subtract fractions? But also pulling simple substitutions from our identity chart over here. So looking at this first part, we say sine times cotangent times secant. You know, maybe what I'm interested in doing here is just making some substitutions. So knowing what I know about sine, I suppose that I would just leave sine as it is. Sine is just sine. But in terms of cotangent, what do I remember about it? Well, I remember cotangent is cosine of our x value, sine over sine of x. I'm not using a theta here because it seems that we have x for our angle. But then secant, what do we know about secant? I know that secant is 1 over the cosine of our angle. So looking at this, I'm going to put my sine x over 1. This is pretty neat, but what we end up with is a situation where if you were to multiply straight across, your sines cancel out here, you get a 1 and a 1 here, and your cosines kick out here and here. We just get 1. So this whole expression that we see right here, another way of writing the same thing would be to say that, well, it just equals 1. Okay, so with respect to number 3, algebraic stuff. Now I don't see any foiling or distributing, but I do notice that both of these terms, they both have a cosine involved with them. So my goal right now is just to kind of try to play around with this, but I think that what if we were to factor out that cosine of our angle? And so what we'd be left with here, sorry, cosine of theta, if we were to bring that cosine of theta out in front, then on the inside we'd be left with 1 minus the sine squared of our angle. And with respect to this, hey, I see a 1, I see a sine squared. I'm thinking this is maybe Pythagorean. So I'm looking at my Pythagorean identity. I know that sine squared plus cosine squared is 1, but how could I rearrange this so that it says 1 minus sine squared? And I hope you see that if you were to take that sine squared and move it over here, what we end up with then is that cosine squared of theta is 1 minus the sine squared of our angle. And so what's true about this is that we can be rewriting it with a cosine of theta. So now we have this, the cosine of theta that was out in front, and 1 minus sine squared, well, that's a cosine squared. And if we take a cosine to the first times cosine to the second, using our rules of exponents, we just get cosine cubed of theta. Okay, so for this last example, I think that I'm going to rewrite it here. We have tan x cosecant x, and this is all over the secant of x. Okay, so in terms of what we could do, I don't see any distributing, I don't see any foiling, I don't see any factoring, you know, I don't see anything going on here, adding or subtracting fractions, nothing. So maybe what I'm looking for is, can we just do some substitutions? So like tangent. What do we know about tangent? Well, I know tangent's sine over cosine here. So let's rewrite tangent as the sine of our angle, x, over the cosine of our angle, x. Our cosecant, well, cosecant, using our reciprocal identities here, cosecant is the reciprocal of sine, so we have 1 over the sine is our cosecant, okay? And this is all over, since this is our numerator, this is all over 1 over the cosine of x, our reciprocal cosine function here. So what I notice now, essentially, is that we are dividing with fractions. And so since we're dividing with fractions, instead of taking everything on the top and dividing by this fraction on the bottom, we're going to take everything on top and multiply by the reciprocal of our denominator. So again, I'm going to rewrite everything on top. We have sine x over cosine x. That's our cotan, or sorry, a tan. And then we have 1 over the sine. This was our cosecant, 1 over the sine of our angle. But instead, we're going to take it times the reciprocal of the denominator, which is cosine x over 1. And so looking across here, this is supposed to be an x, I apologize, and so is this. We get our sines to cancel out, we get our cosines to cancel out. It looks like we get a lot of cancellation going on. And again, this entire expression here can be rewritten as 1. So remember that when you're using your identities, the best thing to do is just kind of plug in substitutions if you can, or do algebraic manipulation to kind of try to simplify it and achieve an easier or simpler expression. Cheers.